I am a professor of water resources at AWRI, and I've been here since 2002. I see myself as doing three main kinds of research, all having to do with the journey of carbon in the biosphere, mainly through aquatic ecosystems, and the role of tiny invisible microbes that we cannot even see, but play the biggest role in them. So the role of microbes in driving the carbon cycle in the hydrosphere. That's what I see. My focus obviously is the Great Lakes and the waters around us right here. I grew up wanting to be a forest ranger like my grandfather. But once my parents took me to the seashores, I fell in love with the ocean. So my training is in oceanography. And when I came to the Great Lakes, I just fell in love with the fresh water that we have here and realized this is the real asset of this nation and this continent. And 21% of freshwater, surface freshwater on the planet in one place. What a great system. And having studied the big oceans, these lakes seem like, oh, maybe I can get a handle on some of the mysteries in the Great Lakes. And that just kept me going for the last 2 decades. I think we realize a lot of it. It is what we can do about it, that's the hard part. We realize that we need it every day, almost every second. We are mostly water, and everything, the food we eat and the water we drink all comes from sources. And the safety of those sources is so essential to our daily lives, because throughout human history, there's no question that water has shaped where we live, how we live, and even if we live. So that is fundamental, and the ties of the Great Lakes community to the Great Lakes is very, very intimate. That we recognize. What do we do about it? That is the hard part. Even though the Great Lakes are big, we realize they can get polluted. They will get affected by the big water cycle that will amplify as global climate warming takes place. What do we do about this? Those are the things that are hard to understand. Just like the oceans, we've been assuming for far too long that the Great Lakes are too big to be impacted. But now that we know more, we see that, the Great Lakes may, they're large, they may have 100 years of residence time, meaning if you empty the Great Lakes, they would fill back with rainfall in 100 years, roughly. Lake Michigan is about 100 years, Lake Erie is about 30 years, Lake Superior is about 300 years, and so on, but average is about 100 years life cycle. So water cycles and comes back, but the pollutants we put in end up staying. So those are concerns. I mean, society should really figure out how vital and central water is to our daily lives, and we should pay as we go for the services we receive from nature, especially from water, because water is integral to all nature, not just humans, but the rest of the biosphere that we depend on. The Earth itself is in what is called the fortunate Goldilocks zone in the solar system. It's located somewhere where it's neither too hot nor too cold. As best as we know, it's the only place in the universe where on the surface of a planet, water exists in all three of its phases: liquid, ice, and as vapor. And these are very important because water came to Earth in its early history through planetesimals and comets and so on. So it's imported material, really. But once the hot Earth started cooling, it was able to retain them. And that retention is very important. It took a long time, but it retained enough, like bulk of the water on Earth now came from original solar material and from comets from elsewhere. The retention was very important because as the Earth cooled, it was able to condense them, and you could get drains that made the oceans fill the lakes and rivers and so on. And The other thing is the vapor stage is just as important, because that the ability of water to retain heat and redistribute it across the planet like a thermostat is really, really vital. So for example, of the global warming we've been doing due to anthropogenic carbon dioxide pollution, etc., over 90% of it is taken up by the water. So it is mitigating the atmospheric temperature increase. How long and how far it can do it is a question, of course. So water is our gigantic, not only life-giving substance, but it's also the big global thermostat. That's going to be amplified most in a hotter world where the atmosphere will become more humid and the big water cycle will chug along. What has been maintaining this Goldilocks planet, and especially in the last 10,000 years, as very conducive to human civilization, may be pushed off the rocker, so to speak, if things continue and the water cycle can't manage the perturbation. So those are big scientific questions we are trying to understand, because stability of the Earth ecosystem is very important for civilization as we know it. For our, from our daily lives to the annual cycles of agriculture and other culture and so on. So very integral, water. That's another big thing. Just like space science is always way ahead of us, ocean science is way ahead of freshwater science. You could argue there's more of the oceans, there's more money in the oceans, and the oceans obviously are so important. Like half of the oxygen we breathe is from ocean plankton. But I think freshwater studies have been less advanced than the oceans. But borrowing from those space and ocean technologies, we are catching up very fast. And we say that freshwaters are one of the most vulnerable ecosystems on the planet now, even including in the sense of not just water quality, but also biodiversity. Freshwater species are more threatened than marine species. And you can say their immediacy, right? We're more immediately involved in fresh water, not only as a drinking water source, but also for other resources. So, I think humanity should invest more in plans for sustained long-term conservation of our freshwater resources. Yeah. How fundamental it is to our lives. Not just our lives, but the rest of the biodiversity that all goes to provide the nature services that we rely on. Today, humanity is we could say, stealing over 50% of the biosphere's productivity. That assumes we are the only ones who have to eat. But there's the rest of the biota that have to go about their daily lives. So as we dominate, we are edging out other species that actually provide the cleaning and the growing services that provide us. So in freshwater, that is no less important, maybe even more important, to conserve and safeguard not only for our health, but the rest of the ecosystem services that freshwater provides us almost endlessly if we take care of it. When you turn on the tap, water comes. So easy it is, but where does it come from? What ensures its quality? What ensures its sustainability? I think these are paramount questions. Increasingly, we can't take it for granted because nearly 2 billion people don't have enough water, they don't have enough of drinkable quality, potable water. These are major concerns for humanity, whether it be in terms of poor health, diseases, or in terms of precipitating wars and famine and other things. So these are societal concerns. I think some of these need to be in the classroom. And it's not that we cannot address them if we recognize the value of these, resources. We just have to recognize their vital role enough that we pay as we go. that we cannot continue to use them without paying for what we take. The fact remains there is no other place in the known universe, despite the James Webb telescope being able to look far deeper into time and far further into space. There's no other place in the known universe that has ubiquitous water in all three of its states, abundant. This is like the perfect home. We have a utopia here. Can we keep it? Those are the real long-term questions. And water is central to everything. And it's difficult to debate that. We have been an institution on the shores of this lake for about 30 years or more. But only in the last 12 years, since we had this observatory that had a met tower on the top and sensor clusters at 4 depths, all the way to the bottom, have we been able to see, there are strange things happening in the interior of the lake. For example, we had clues about surface blooms because we could see that. But we didn't know how deep they penetrate. We know now. For example, we didn't know the bottom water of the lake here, Muskegon Lake, annually, repeatedly undergoes hypoxia, meaning low oxygen. Oxygen low enough that fishes choke and invertebrates can't breathe. Okay, only microbes can exist there. So this kind of habitat degradation that's annually occurs, those mysteries were not revealed in all those previous years we have been here, out and about, randomly sampling in good weather days. Now and then we miss those things. So careful, detailed observations can reveal a lot about ecosystems, the mysteries of ecosystems, which we need. Okay, that's one thing. And we also know now how we can track how daily the system grows and resets. Like oxygen in the summer, on a day like this, plants will make oxygen during the day, then animals and plants too will consume that down. So there's a daily reset, and this thing repeats over the seasons, and there's an annual reset. And for example, the observatory has shown us that even in the winter, even when it's ice covered, there are things that happen in the lake that are very important for resetting the system for the next spring bloom, the growth cycle to begin again. So, some observations like that have revealed to us things that we did not know before. We have right here in the Great Lakes analogs of the deep sea thermal vents, windows into the distant past, and platforms here, like right here, where we can look at the day-to-day urbanized influence of the industries and the agriculture on the second largest watershed in Michigan. Right here, this is like the terminal point of the watershed. Everything comes here, and this lake is a great sentinel of all the changes that are happening in the watershed. So it's like a memory book. If you can read it, you can tell a lot of stories. And that's what we've been finding out with the every 5-minute meteorological sense data we have for the lake, and every 15-minute water quality data at different depths. We are now able to tell those, read the lake like a symphony, like musicians read notes, ecologists can read numbers now, and you can really paint that scenario. And over a long time, you should be able to also tell if things like climate change, climate warming are affecting the lake, shifting these daily and seasonal rhythms differently than before, those kind of things. So, basically looking at changes. We hope things improve over time. The lake certainly has improved, but it still has a long way to go. The undervalue of water that humanity has managed to do, monetize it and privatize it, and how collectively we have not cared enough about water quality and water access in the global south. those things bother me, because I think water is a truly global commons, because the water that evaporates here today is going to rain in India tomorrow, in the next several months, in the coming monsoon. And what rains there is going to show up here in the Great Lakes in a couple of years or so on. So there's nothing more. It's as a water vapor, it moves just as fast as the air. So it is, it's everywhere. It's ubiquitous, truly a global commons, and there should be a global water university, to really ponder these big questions and how we can make it work not only for humanity and our civilization, but also for the rest of the planetary travelers. Every time we deny water, like you could say, if the hypoxia amplifies here, we are denying is 1/3 of the lake bottom access to even migratory fishes. Now there is a thriving sturgeon population now that requires to migrate through this bottleneck. Okay, and we deny that habitat, and they have to come up with strategies. Not all are able to change, when the changes are too big. So there's a lot of reason why we need to conserve our freshwater resources, and sustainability should be at the core of it, to make these solutions work long term and for all of us, not just people, but also the ambient residents, fishes to microbes and so on, birds and so on. What one person can do is important. Obviously, they can use less of it. There's no reason as Americans we should be using 30 times more than the average person in any of the 54 countries in Africa. So we could obviously do a better job of that, and that's the starting point. But I think there has to be societal changes too, about how we value water and how we maintain our water resources. Too often it is the responsibilities are shunted to the individual, and these are the usual, deflect, deny, disinform kind of strategies. Like you and I, to get to work, if you don't have public transportation, we end up driving, right? Yeah, and so if their options are there, things would work out, and that as a society has to work on those better options, and not just charge the individuals with taking responsibility. Personally, it is obviously necessary that individuals take responsibility and participate, but it is a diversion. It's a diversion, so the not pay as you go, business as usual, where profit is everything, can continue to go on with, saying, oh, if you as a person can make all the difference. Yes, but with huge constraints. So that's where I think societal changes have to come in. Right? We truly are. And that may be the most important realization Great Lakes community can have, because, it's been said before, we only say what we love, or at least we do our damn best to say what we truly love. And to truly love, sometimes you have to know the value of something like this, the resource. I mean, water is life. I mean, what's wrong with loving life? And deeply enough to care enough to save it for not just us, as the Iroquois ideology says, for the 7th generation. Why not for thousands of years into the future? There's every reason to think that there will be billions of in a safely managed planet. In this new Anthropocene, a safely managed planet, there will be billions of people who will follow us into the future, into thousands, maybe even millions of years into the future. If you assume the average species on Earth so far has been given the right conditions over the last 3.5 billion years or so, has made it to 2 to 20 million years or so on the average, humanity is still a long way to go. Long way to go, and so we could even, do we really have to care about future generations? The ones who have done nothing for us and ones who have not yet seen? Those are also big long-term questions we have to come up with. I personally think we owe them a lot, just like we owe our children, what kind of world they will walk into. So there's good reason to think we need to think long-term. And it's not enough to be conservative, so just for today, tomorrow it can go to dogs. We have to think very, very long term, and maybe even thousands of years won't be a bad idea at all. And then we'll try to get it more or less right. Yeah, and I think also it's wrong to put our hopes on technology, wrong to put all the weight of the mess we do on the planet on our children and their children. We need to take responsibility. And again, there too, there's only that much as an individual you can do. And that's correct, one should do. But as a society, we need to make the right changes and make those bigger, long-lasting changes possible.